All right, let's talk about a piece of technology that is literally all around us but completely invisible: Wi-Fi. Every single time you stream a movie, hop on a video call, or just scroll through your phone, you are using this incredibly powerful and complex standard called IEEE 802.11. So let's break down how it all really works. Think about it. You use it every day, all day. But have you ever actually stopped to ask, how? What is really going on behind the scenes to send all that data flying through the air from your router to your laptop? Well, that's exactly what we're going to get into.
So first up, what even is Wi-Fi? Let's start with the big picture. To get there, we first have to talk about this term WLAN. It just stands for Wireless Local Area Network. And really, it's the broad name for any tech that connects your devices together in a small area, like your house or an office, using radio waves instead of plugging in a bunch of cables. It's the whole concept that lets you walk around with your laptop without being tethered to a wall.
Okay, and this is the most important part. If WLAN is the general idea, then IEEE 802.11 is the specific official rulebook that actually is Wi-Fi. It's the universal language that every single Wi-Fi device in the world agrees to speak. It defines everything, from the physical radio signals all the way up to how devices politely share the airwaves.
So how are these networks actually built? Let's look at Wi-Fi's basic blueprint, because there are really two fundamental ways to set things up.
On the left, you've got what's called infrastructure mode. This is what you and I use pretty much all the time. All of your devices, your phone, your laptop, your TV, they all connect to a central hub, which is your router or access point. Now on the right is ad hoc mode, which is totally different. It's direct device-to-device communication, no router needed at all. It's like a direct digital handshake between two computers.
And all of these wireless conversations, they have to happen somewhere, right? They happen on specific radio frequencies, and you can think of them as different highways for all your data. The most common ones you've probably seen are the 2.4 and the 5 gigahertz bands. And just recently, Wi-Fi 6E has opened up this brand new, wide-open superhighway, the 6 gigahertz band, which means way more space and way more speed.
Okay, Section 3. Now for the really fun stuff. Let's pop the hood and take a look inside Wi-Fi's engine room to see how it actually works.
I absolutely love this analogy because it makes the two most important parts of Wi-Fi so clear. You've got the physical layer, or Fi layer. That's like the actual mechanics of your voice, producing the sound waves. And then you have the Mac layer. That's the social etiquette. It's the rules we all follow to make sure we don't just talk over each other. And you need both to have a clear conversation.
Now, if we dig into that PSY layer, the speaking part, we find some seriously clever tech. OFDM, for instance, is a genius way of splitting one big data highway into hundreds of smaller parallel lanes. This makes the signal way more robust. And then you've got MIMO, which uses multiple antennas to send and receive multiple streams of data at the same time. It's literally like talking with multiple mouths and listening with multiple ears simultaneously. These two are the real workhorses behind modern Wi-Fi speeds.
And what about that social etiquette? Well, the Mac layer's golden rule is a protocol called CSMA/CA. Now that stands for Carrier Sense Multiple Access with Collision Avoidance, which is just a very fancy technical way of saying listen before you talk. It's the traffic cop that prevents total chaos on the airwaves. And this is how it works, and it's brilliantly simple. First, a device listens to see if the channel is empty. If it's quiet, great, it sends its data. But, and this is the key, if it hears someone else talking, it doesn't just barge in. It waits for a random, tiny slice of a second, and then it listens again. It's this simple act of politeness that lets dozens of your devices share the same Wi-Fi channel without a problem.
So we know how it works now, but believe me, Wi-Fi wasn't always this fast. The way it's evolved over the years is just incredible.
This timeline really shows the journey. We started way back in 1999 with 802.11b. Then came the big upgrades. 802.11g brought us that super efficient OFDM technology we just talked about. Then 802.11n gave us the multi-antenna power of MIMO. Each new version built on the last, getting faster and smarter all the way up to the standards we use today.
So back in those early days, with that original 802.1b standard, the absolute fastest you could possibly get was just 11 megabits per second. That was fine for some basic web pages, but that's about it.
Now, fast forward to today, thanks to all those innovations, the current standard, 802.11ax, which you probably know as Wi-Fi 6, has a theoretical top speed of up to 9.6 gigabits per second. That is a nearly 900 times increase.
It's a truly mind-blowing leap in performance.
And one of the most important new tricks in Wi-Fi 6 isn't just about raw speed, it's about being smarter. It introduced something called OFDM, which lets the router talk to multiple devices at the same time by neatly dividing up the channel. This is an absolute game changer for efficiency in crowded places like an airport or a coffee shop. And here's a cool fact. This idea was actually borrowed directly from 5G cellular tech, which just goes to show how these wireless worlds are starting to come together.
All right, so we've covered the what and the how. For our last section, let's pull back and put this all in context and talk about why it really matters. This is a really great way to see where Wi-Fi fits in, especially when you compare it to 5G. You see, Wi-Fi is an IEEE standard that's built for short-range, indoor use, and it uses that polite, listen-before-talk method. Cellular, on the other hand, comes from a different group, is built for huge, wide-area mobile networks, and uses a much more controlled, scheduled system. They're really partners, not competitors.
I mean, when you look at the benefits, it's no surprise that Wi-Fi has taken over the world. It's so easy to set up, it frees us from being tied down by cables, the speeds are incredible, and it gives us that flexible connection that our modern lives just demand.
But of course, nothing's perfect. There are always trade-offs. Wi-Fi's range is pretty limited. It can get all messed up by interference from things like your microwave, and that polite access method can get sluggish if too many devices are trying to talk at once. And of course, security is a huge deal if it's not set up right.
So why should you actually care about all this technical stuff? Because these core ideas, OFDM, MIMO, and these MAC protocols, they aren't just for Wi-Fi. They are the fundamental building blocks of almost every modern wireless system out there. If you get these, you have a much better handle on everything from your home router to the 5G network on your phone.
So, let's wrap it up with the 3 big takeaways. Number 1, IEEE 802.11 is the official rulebook that defines what Wi-Fi is. 2, it uses incredible technologies like OFDM and MIMO to send signals really fast and reliably. And 3, it uses the simple, polite CSMA/CA system to make sure all our devices can share the airwaves without chaos. And all this leaves us with a really fascinating question for the future. As these two incredibly powerful technologies, Wi-Fi and 5G, keep evolving and even start to merge, what's next? How is our seamlessly connected world going to change?